Hi everyone, welcome back to my channel. Today we will talk about Google Cloud Composer. Composer is the Google service which provides a managed Airflow instance. Apache Airflow is one of the most popular workflow orchestrator and scheduler in data engineering world. It provides you not only scheduling capabilities, but it also provides you capabilities of building really complex data pipelines by chaining small tasks together. It has a lot of different tasks supported, be it creating infrastructure components, taking decisions, branching, forking, running in parallel. There are myriad of ways in which you can chain your different tasks together to make a workflow in Airflow. The best part about Airflow is that all of this can be programmatically done. So Airflow supports creating workflows or DAGs, directed acyclic graphs, using Python. However, one of the biggest challenge with Airflow is that running and maintaining the infrastructure for Airflow is quite challenging. Airflow as a single instance has lots and lots of moving pieces. It has scheduler, it has a web server, it has a SQL database where it keeps all of its metadata. It has a folder where you'll keep the tags, and to top it all off, if you are running all of this in a single instance, you do not have the scalability. Also, you have a single point of failure, and Airflow scheduler is notoriously known uh, for consuming a lot of memory and a lot of CPUs. So if you are running all of this on a single machine, you run the risk of your Airflow being down, right? Then the monitoring of your Airflow instances is also a challenging task, right? So what Google Cloud Composer do is that it provides a managed service for Airflow. So you do not have to manage the underlying infrastructure. You just go there, create the Airflow environment, and start using it without any hassle. Google will automatically provision all of the required components underneath. So in this video, we will see how you can set up an Airflow environment, or rather I should say a Google Cloud Composer environment, and what are all of the different components that are available, or what are all the different components which gets created underneath without you knowing. So let's get started. So first, what I'm going to do is that from the left menu, I will go and scroll down to the big data section where I will find my composer. You might see an enable API prompt if you are using it for the first time. Since I have created environments before, I did not get that prompt. So if you hit on create environment, you will see that it is asking you to select one out of two versions, which says Composer 1 and Composer 2. And the Composer 2 is in the preview. So you can see some of the highlights that the Composer 1 or the version 1 do not support the auto scaling versus Composer version 2 supports the auto scaling. Interesting. You want to read more about it? You can open up the documentation, and here you will see that the Cloud Composer version 2 is in pre-general availability, which essentially means that the API might change. The SLA is quite different as well. So one of the major difference you see is the environment. So in Cloud Composer version 1, you run on a standard mode Kubernetes engine, versus in Composer version 2, you run it on an autopilot Kubernetes engine, which essentially means it also supports auto scaling of the workloads. So if you come slightly down, you will see horizontal scaling is available for both of the versions, but in version 2, it is automatically scaled, versus in version 1, you'll have to manually scale it. So that's the difference. Also, the version 1 supports Airflow 1.10 as well, plus the Airflow 2, versus the version 2 only supports Airflow 2, and subsequently the Python version 3 only. So these are some of the differences. There are differences in the architectures as well. So you can come down and you can see the different architectures. But in this demo, we will be using Cloud Composer 1 since we just want to use the concrete API which is available. First, it asks you for a name for your Airflow environment. So I will say, let's say, development. Next, it will ask you to select for a region. I will select US Central 1 because I have all the quotas available there. Then it will ask you how many nodes should the Google Kubernetes Engine should have, and anything below 3 won't work. So it says it should have minimum of 3 nodes. So that is there. You can have more nodes as well, but 3 should be fine. Then it asks you to select the machine type. By default, it is N1 standard 1, which is good. By default, the disk size is 100 GB. We don't need that, so we will put it as 20 GB. The OAuth scope, the scope of the VMs, by default, it is allow all, which is the little string here. So I will allow it. I will be using the default compute engine service account. The tags here, I will choose the image version. So I will use the latest image that is there, which has Airflow 2.1.2. And when I choose this, I can only choose Python version 3 because Airflow version 2.1.2 only supports Python version 3. Next, it asks you how many schedulers should I have. I can run more than one scheduler for resiliency. I can run 2, I can run 3, but I cannot run more than, the number of nodes I have. So if I enter 4 here, it will say it cannot be larger than the current node count. So I will move back it to 1. I do not need that resiliency as of now, but in production environment, you might want to turn it up to the number of nodes, or at least greater than 2. Right. Here you will choose the Cloud SQL machine. I will choose the default, which is the smallest machine, N1 standard 2. Then it will choose the default network, default subnetwork, and I will say that I want to allow access to from the entire internet. And then you will choose the web server machine as well. So it is again the default one, and one web server 2. So a nice thing about Cloud Composer is that every time you create an environment, Cloud Composer behind the scene creates a tenant project. And in that tenant project, Cloud Composer installs or spins up a App Engine flexible instance, which runs the Airflow web server, and a Google Cloud SQL instance, which we have just configured here. So you won't see these two services running in your own project. You will see the Kubernetes engine running in your own project. You will see a lot of PubSub topics and subscriptions getting created, which Composer internally uses for communication as well in your project. But the web UI, which runs on App Engine Flexible, and the Cloud SQL instance, you won't see these two in your project. There will be a tenant project that gets created behind the scenes by Google, and those two components will run in there. Now, if you want to see there, you can see the architecture. So here is the complete architecture of that. And here you will see, if I expand this, so it is a tenant project, and the Airflow database, which is Cloud SQL, and the Airflow Web UI, which is the App Engine Flexible, that gets created into the tenant project, and also a cloud storage bucket for database backups. But do not confuse this cloud storage bucket with the bucket where you will keep the DAGs. That's the environment bucket, and that's in the customer project. That means the project we are working on. Right. So those are a few of the things that you should just know. You actually do not need to know these things because these things are handled behind the scenes, but you should know that these are the components which will cost you. So I'll hit on create, and it should take roughly around 5 minutes for this to get created. So after almost 15 minutes, give or take, the environment is ready. So let's jump right into it. So what I will do is that I will hit the development environment name, and it should open the Pandora's box. Right, there are lots and lots of tabs over here. So first, what I want to do is I want to come to the environment configuration tab, which is the details about my environment. So the name, the location, the service account, the API scope, the image version, all of the things which we have selected. But here you will see two links. So one is the link to the bucket where the DAGs are kept. So I'll open that up. And the second one is the Airflow Web UI, right? So the Web UI, as you remember, as I mentioned, that Web UI is running in a separate tenant project in App Engine Flexible Instance. So it is guarded by IAP, which is Identity Aware Proxy. So that's a Google component. If you want me to cover that as well, just comment down below and I will cover that as well. And here you go. Right, you have the Airflow UI available. And here you will see that there is an Airflow underscore monitoring DAG, which is already there. So this is a DAG which periodically runs and sends back the stats to the Google monitoring, or cloud monitoring rather, I should say. And then those stats are available here in the monitoring tab. Right. So here you will see that in the DAG folder, in the bucket, you have Airflow monitoring PY, which is responsible for this DAG. Now, I quickly want to show you some things. So first, what I want to show you is that I will come down to the Google Kubernetes Engine, and I will show you that indeed there is a 3-node cluster running, right? This is the cluster in which you have your Airflow components, which is Airflow scheduler and Airflow workers running. So if I come here and I come onto the workloads, you will see there are lots and lots of services running. So here you will see that there is a job type, the Airflow database init, which is in error state. I don't know, the Airflow seems to work fine. We will see that. Then there is Airflow monitoring, which is a deployment. Then there is Airflow Redis, which is stateful set, scheduler as a deployment, SQL proxy as a deployment, workers as a deployment. So there are 3 pods, 1 pod on each node. And then there is a composer agent, which is a job, which is not running right now. And then there is a Fluentity daemon, which is running as a daemon set. So you see, you have lots of things running, and then you have a lot of cluster IP services, which are internally used by different Airflow components. Right, that's part number 1. Then I want to show you the topics and the subscriptions which are created. So we will again come down to the big data section and open PubSub. Right. And in the PubSub, you will see that here 3 topics are created. One is for composer agent to backend, and one is for composer backend to agent. And there is this rollback topic. So let us open any one of it and let us see if there are some messages. So you see that there were some messages published into this. So this topic is used to provide commands or, update actions to the composer environment. So the composer environment and the GKE talks with each other using these PubSub topics. And you will see in the other topic as well, you have some messages. Let us try to see if we can read some of those messages, right? So I will select the subscription and I will say pull. I will not do enable act because that would acknowledge the messages. And you will see some of those messages which were shared. You should see, okay, we do not see that because I believe they have been act already. So yeah, there are no unread messages as of now. Let me go back into this topic. Can I read some of the messages in this topic? Let me check. I'm assuming that all of them have been read already. Yeah, so you do see this message. It seems to be gibberish, possibly encrypted, but you do see that how these messages are being exchanged, right? And similarly, there is corresponding subscription to these topics as well. So that's how, and you have already seen the bucket. So you have seen how these components are getting deployed within your project. So Google Cloud Composer is just a wrapper over all of these services, right? And as I mentioned as well, that the Cloud SQL and App Engine are not present in this particular project. They're in a tenant project which is created in the background. So here you will see there is no Cloud SQL instance running. So yeah, the architecture stands correct. So what I will do is that I will close down all of the other UIs and I will just keep the environment and the Airflow, right? So I will refresh this page and you should see that the execution is complete. So I have copied the demo DAG, which is available in the Airflow tutorial, and we are going to copy that DAG over to our bucket, which will get synced to our Airflow, and then we'll run it, right? We will just see whether our Airflow installation is working or not. So let me take you to the DAG. Exactly. So this is the DAG which is there. I'll walk you through this DAG, but I am not going to go into the details of what all tasks and what all configurations are present. So we are using something known as a bash operator, which has a task ID and a command, right? At the very least. And then it has other things such as retries, depends on the past, so on and so forth. But the basic things are task ID and the bash command. And if you see here, by at the end, what we are doing is that we're chaining all of these tasks together. So once the task 1 is complete, task 2 and 3 can run in parallel. That's essentially what we are doing. Right. So now what we're going to do is that we are going to grab the bucket details from the environment configuration page. So we will copy this details. And then what we will do is that we will go to our command line. What I'm going to do is I am going to copy sample.py to this particular location where the tags are supposed to be put, and it is done. So now I will wait for it to show up on my DAGs page. There, yeah, so you see tutorials is there, and there are 2 instances running because the way it was configured is that it was supposed to start 2 days before, so it is just backfilling those runs. So that's how it is running, right? It is, so our Airflow installation is working. You see the graph, which is the printed, the sleep, and the templated. We are not dealing with the specifics of the task, but you see how it works. Now an important question comes up, right? Why I should choose a managed service? If you go to the Composer pricing, right? Sorry, I should say GCP Composer pricing, right? You will see that the Composer is not a cheap component. There are a lot of things which are included. So we are using Composer version 1, so we will see what all SKUs are attached to it. So there is a vCPU for web server machine, there is a vCPU for SQL machine, there is, you know, disk and web server machine for the Kubernetes engine, there is cost for the disks on the database, there is network egress cost as well, right? So there are a lot of components that are available, and if you look at the pricing, it is not cheap, right? By any means, it is not cheap. So you would ask me that, Sushil, why should we use a managed services? Why can't I hack together an Airflow installation? We have, so you might ask that we already have a Kubernetes engine running. Why can't our ops team run the Airflow themselves? And I would say, yeah, you can pretty much do that. You can run the web scheduler and the web server and the task queues and the workers and the Redis all yourself. You can even create services to sync the DAGs from the bucket because Airflow do not support that out of the box. So you can do that as well. And even if you do not have a Kubernetes engine, you can pretty much do the same with Google Compute instances as well. You can have your web server running in a separate machine, a scheduler running in a separate machine, and task or the workers running in separate machines, right? You can achieve the somewhat same level of resiliency and availability yourself as well. But one very key differentiating factor which I find with Cloud Composer is the way logging and monitoring is integrated, right? The level of logging and monitoring that you get with Composer, that is unparalleled. You need to have a really mature ops team, and I would not put it on team, rather I would say you need to have really mature ops practices of logging and monitoring in your team to match this level of to match the level of monitoring and logging that is provided to you out of the box by Cloud Composer. That's point number 1. We will see in some time that what all components or what all information is available. But the second point why I am forcing or why I'm stressing on monitoring and logging is because Airflow is the central component of your data pipelines. In many of the organizations which are batch oriented, or even even in the organizations which are streaming oriented, but they still have like a lot of batch services running or batch jobs there, which are completely dependent on Airflow, right? So Airflow becomes the central key piece within your data engineering team. If your Airflow is not available, you might run the risk of breaching some of those SLAs on the reports, on the data that you provide back to the client, the reports that you send to your execs. You might be putting them in jeopardy. So that's why even Composer puts a lot of effort on the monitoring and logging and making sure that your Airflow is highly scalable and resilient. It should be available, it should be able to schedule your tasks, it should be able to execute your DAGs. So that's what the key motto of Cloud Composer is, and I guess that's where the actual value of Composer comes in. So let us look at the monitoring tab, right? So this is the monitoring tab, this is the environment overview. So you will say environment health for Airflow monitoring tab. You will see it has CPU matrices per node. So you have 3 nodes, you see 3 CPU matrices. You have memory per node. If you talk about SQL databases or the SQL database, you get the same information around CPU usage, memory usage, disk usage. You get the same information about the web server, the CPU usage, the memory usage. Then when we talk about Airflow scheduler and workers, you will see the active workers. So there are 3 active workers. If any pod was evicted, if any zombie tasks were killed, how many successful DAG runs you have, how many failed DAG runs you have, if are there any failed tasks. You can see more DAG matrices such as how many completed DAG runs are there, what is the median DAG duration, how many tasks are completed, DAG bag size, parser accounts, total parse time, right, so on and so forth. This is a lot of information, and if you are hacking together a solution, or even if you have a very sophisticated Airflow installation, to get to this level of matrices, to get to this level of information, you need to have really involved uh you know operational practices. And this is just monitoring bit. Let us come to the over to the logs, and here you will see that there is lots and lots of logs. You can see all of the logs here, right? With this console, you can see scheduler logs here separately, you can see worker logs here. So each worker log is present there. You can see that processor manager logs here. You can see Cloud Composer agent logs here. You can see database operations log here as well. SQL component, SQL proxy, Redis, sync, all of the logs are present here, right? So that is where the value of Composer comes in, right? You get a really resilient and highly available and horizontally and vertically scalable Airflow installation, which is latest and greatest of Airflow out there. Plus, you get all of the monitoring and logging bundled with it. So that's like best of the both worlds. In my opinion, that's where the value of Cloud Composer comes in. So that is pretty much it for this particular video. I hope you enjoyed the content. I have covered almost all of the aspects of Cloud Composer. But if you feel that I have missed something, or if you want to know something else, please do let me know down in the comment section, and I will definitely create a part 2 of this video and cover the missing topics. And if you like the content, please like this video. And if you enjoy such content, do subscribe to the channel and hit the bell icon so that you get the notification and you do not miss the newer content. And with that, thank you so much, and I'll see you in the next video. Bye bye.